Okay, so we are in Statistical Rethinking, second edition, chapter 15. We're in the medium questions, question 15 M3. Make sure that you have, that if you're using a Colab sheet, that you're in R up here. And make sure that you've ran all this code up here before doing any of this. Okay, so we're going to go back through a model from the chapter, the waffle divorce data set. And if you recall from the chapter, there is measurement error in the divorce rates, okay, for each state. And so what we're going to do is we're going to double the standard errors, so just more, uncertainty, more measurement error, and then explain, what happens to inference with all of this. Okay, so in this first part, I'm just copy pasting from the chapter, and to double the standard error up here in the data, I've just multiplied DSD by 2. Okay. So when you run this, it runs fairly quickly, but you get this error right here, this BFMI error. So the book only talks a little bit about this error. To really understand it, you kind of have to understand how the Hamiltonian Monte Carlo is working, like the actual algorithm. And so every time I get this error, I fret deeply because I have to go back through and remember how that algorithm works completely. But more or less the heuristic I've internalized with this is that you have a posterior distribution that is just very, very broad, such that the that the Markov chains are having difficulty exploring all of it. So either too broad or too tortuous or something like that. But anyway, one of the ways that we can try to remedy this situation is to use a non-centered parameterization. There we go. So that's just what I've done here, and you can look at how I've done this. But now D true is being replaced by kind of the action of the non-centered parameterization. But when we go through and we run this, again, it runs pretty quickly, and we don't have any of those errors. So running the pricey output, we get this, and we're supposed to say, what's the difference then with what we got in the chapter. So I've just copied and pasted the pricey output from the chapter here. Okay. And so if we just kind of go item by item here, so if we look at A, the intercept, it's a little different. I would guess that it's basically the same. And same for BA, it's slightly different, but it's, roughly the same. But now when we get to BM, this is marriage rate, it seems like there is a fairly substantial difference with marriage rate. It's not really clear, but it seems to be. And then sigma has also been reduced pretty considerably here. Okay. I don't have a great explanation as to why, but apparently what's going on is that when we double the the standard error for the divorce rate, for the estimates of the divorce rate in each of these states, well, somehow we are changing how much influence each state has over the estimates that the model is making. I mean, that's almost a tautology, but maybe that's about as good of a explanation as I can give here. I'm not really sure why sigma is changing, but if you do, then let me know in the comments. I suspect that maybe it has something to do with overall broader credibility intervals in the other coefficients, and therefore that's a lot of the uncertainty is being kind of sucked up here, but could also have something to do with the non-centered parameterization. I'm not sure. I don't think that's the case. But anyway, I'm not really sure about sigma. If you have a good answer, then let me know in the comments.